Hello, welcome back to the last two presentations of the first day of the Android Security Symposium 2017. We now hear a talk of Joshua and Michael, who are from NIST and MITRE, if I'm spelling that correctly. And we are going to focus here on threat models for the mobile ecosystem. So yeah, stage is all yours.
Thank you kindly. Howdy everyone, my name is Joshua Franklin. I am from NIST. I am a security engineer there. I have a master's degree in information security from George Mason University, and I focus on electronic voting, cellular security, and enterprise mobility.
Hi, can everybody hear me okay? My name's Michael Peck. I work at the MITRE Corporation. MITRE's a not-for-profit independent organization. We do a lot of research, development, and objective analysis work, mainly with the United States government. And I've done a lot of work at MITRE, mainly in the mobile security space.
Excellent. So y'all probably know NIST from things like standardizing AES. But NIST recently started up its own, basically national lab for cyber security. Its goal is to basically, whoops, microphone fell off. Its goal is to basically help secure enterprises and other organizations within the U.S. It is typically public facing, and so we are basically trying to help out U.S. businesses. But just like any other piece of NIST work, it can definitely be used by anyone across the globe. So this lab is called the National Cybersecurity Center of Excellence. It is sponsored both from the federal U.S. government and the state of Maryland. It is basically bringing together academics, government officials, and folks from industry to basically solve these difficult cybersecurity challenges. And so we have been basically getting a large number of companies on board to help solve these security issues. We basically bring in folks who have expertise in this area, and then we build an entire working reference architecture that someone can basically pick up and implement step by step. We are talking every single bash command and every single firewall configuration. And it's really supposed to help show how to use these really neat, new, and great cybersecurity products in a way to help your organization. So we've already done at least one piece of work in mobility. Last year, we created it's basically an enterprise mobility reference architecture. If you want to take a look at it, you can just type in NIST SP1800-4, because we give awesome names that are really not cryptic at all. And it's basically using Lookout, Intel, Symantec, and Microsoft. We got each of those companies together, and we ended up creating this system here that you see. It was basically based on Microsoft Intune with Lookout, and we created this large working network. And so when we did that and we published all the information about how to do it, we started getting feedback, and we got lots of feedback. And everyone had their own thought of how we could improve it. But one of the big things that we heard is that there's no standardized threat model for mobile. And folks were definitely disagreeing on what that even meant. So we take our public feedback pretty seriously, and so we ended up creating this thing called the Mobile Threat Catalogue. It is basically a collection of every single mobile threat that we could really think of. It is meant to be exhaustive. It is by no means there yet. It is something that we are continuously building and improving upon. It is on GitHub, and so folks are basically opening issues and saying you should provide some more information here. It has this overall goal of forming risk assessments, building threat models, and really helping people understand how to mitigate those threats that this catalog identifies. To start, we basically did a baseline review of every single piece of mobile security literature out there. We looked at the entire threat landscape, and we brought companies in to tell us what we should be focusing on. And in the end, this every single threat that we identified has this information: threat category, origin, exploit example, CVE reference number if available, and then countermeasure. And we also include all of the publications and articles that are relevant for this threat. We are definitely thinking that, at least to our knowledge, it is the largest compendium of mobile security information out there right now. I know that definitely sounds braggadocious, but it was a fairly large undertaking, and we are very, very proud of it. Here are some of the high-level category types. Each of these high-level category types have subtypes as well. So application, authentication, cellular, ecosystem, mobile device, and then network interfaces. So this is where we started with the device itself. We basically tried to identify every major component and then look at previously known threats and issues and exploits that existed for each component in the hardware, firmware, OS, app, and then overall device layer. Network interface. I/O is definitely important with phones, and so we were looking at all the previous information related to this. And this definitely includes GPS, the actual power sync cable, and SD cards. And then we also looked at the cellular network. We have a lot of folks at NIST who have expertise in basically telecommunications security. And so with all this in mind, I mean, this is definitely not going to be all useful to a given business. For instance, if they are doing their own risk assessment, they are definitely only going to need a subset of the information presented here, and that's basically going to be true for any organization. Because, for instance, a lot of folks just aren't going to worry about cellular, and frankly, there's just not a lot of things that a mom and pop business can really do about it. For an example of the type of information that's included. So here is the air interface eavesdropping threat. So you can see the threat category, a unique ID associated with that threat. We are definitely hoping that if folks are going to be building their own threat models, they can just use this unique identifier, and then everyone really understands what they're talking about. We have exploit examples and tons of references, and then the countermeasures / mitigations there are basically put into buckets by who would actually perform what mitigation. And that was definitely a big piece of public feedback that we got on this. In terms of additional mitigations, in this individual instance, the actual air interface, the communications channel between your phone and the base station isn't always encrypted, and the 3GPP standards don't mandate cryptographic confidentiality across that interface. And so this is definitely something that if you're worried about cellular communications, then you should be worried about air interface eavesdropping. Here in LTE is what this is talking about. There are actually 3 different algorithms that can be used. One from Sweden, which is Snow 3G, one standardized by NIST, which is AES, and then there's Zook, which is this Chinese cipher that's kind of new and really hasn't gotten a lot of attention yet. What you have there on the bottom left is a packet capture on our cellular network at NIST that we have up and running. And what you see there is that although 3GPP standardizes 3, many of the devices and cores and eNode Bs / base stations that we're using actually have enough extensibility to go out to 7 different cryptographic algorithms. Yeah, and so with that, all of our information has been, myself and Mike Peck have been working on this Mobile Threat Catalog for some time, and so a lot of this Mobile Threat Catalog information was passed to Mike, and he did some really interesting things with it that he's going to talk about now.
Yes, I'll talk about our follow-on activity to the Mobile Threat Catalog. We have this project at MITRE over the last couple of years called ATT&CK, which stands for Adversarial Tactics, Techniques, and Common Knowledge. And so there's a public website at attack.mitre.org, a MediaWiki instance there that I encourage everybody to take a look at. And so ATT&CK's really focused on portraying the tactics and techniques that are used by advanced adversaries. And so usually there's what we call a cyber attack life cycle that portrays the steps that an adversary takes of how they get an initial presence on an endpoint device and then what they do to make use of that presence to accomplish their adversarial objectives. And so ATT&CK has been primarily focused on enterprise Windows PCs, and it's been based on a real threat data that we've collected of public instances that have happened. And for each of these tactic categories, these things on the top right, these attacks been focused on primarily on once someone's on that device, what are those sort of post-compromise techniques that we've seen them use. And there hasn't been as much focus so far on how do they get on that device in the first place, just an assumption that they're there. And so there's a detailed techniques under each of those categories, and for each technique there's a technical description of how it works. There's a list of detection analytics. So these are what are things that enterprise can do, either with software running on those endpoint PCs, or certain things they're looking for from network sensors to see if there's an adversary that's making use of one of those techniques. And then mitigation techniques, meaning is there some way you can configure the operating system so that that technique can be no longer used, or just things like as simple as, hey, upgrade to the latest version and this technique's no longer applicable. And so what we've done is taken ATT&CK and built what we call a mobile profile of it. And so this has been generalized to cover both iOS and Android. And we've looked at really the whole life cycle. So on the left there, what are the types of tactics that an adversary can use to get some sort of initial presence so that they're running code on a mobile device? And then on the top right, what are all the tactics that they're using, say, to escalate privileges or maintain persistence or collect sensitive data and then exfiltrate that sensitive data back to themselves. And so there's a lot of use cases around both the general attack and the attack mobile profile. The two that are in bold are the ones that I'll show examples of those in the upcoming slides. But If we're looking at, say, the techniques a specific adversary used or something that a piece of malware did, this is a good way to highlight those and pictorially describe those. It's a good way for an enterprise to do some sort of gap analysis. So look at the defenses they have in place and figure out if those are adequately covering all of the known techniques. And also for an enterprise to think about what sort of mitigation or detection strategies should we employ. Or if we're doing security testing against ourselves, how can we formulate some sort of plan of what to try against our defenses? And so we also thought, hey, we can't just focus on the mobile device itself. There's this whole mobile ecosystem. If the mobile device is too hardened of a target, an adversary could very well go after other infrastructure components. There's a lot of security dependencies of the device on, say, the mobile network operator or on the device vendor and on various cloud services. And so we have another section of the attack mobile profile that I'll show that describes something called network-based effects, which is, hey, the adversary is not on the device itself, but maybe there's some other things they can do if they control parts of the network environment. And so I have a few example slides of how the attack mobile profile can be used. And so this is the attack matrix where essentially on this top row colored in blue, these are all those tactic categories that were a few slides ago. And then under each tactic, there's this list of specific techniques for each category. And so in this example, I've colored in orange the techniques that were used by this attack that was described by Lookout and Citizen Lab over the summer. It was an attack against a human rights activist in the Middle East. And the way it worked was he received a text message, and the text message contained a link to a website. So there's the malicious SMS message, and then the malicious web content, which triggered a vulnerability in the iOS Safari web browser, and then they were able to escalate and get access to the mobile device and the operating system. This is kind of a unique example because I feel like normally an adversary would get presence by getting some sort of malicious app running on the device. That's the most obvious way to get code execution, but certainly there's other methods as well. And so then once they're on that device, what are the kinds of techniques that they were actually making use of? And so in the case of that Pegasus malware, there's persistence achieved by modifying a system partition. And first there was privilege escalation by exploiting a iOS vulnerability. There were all sorts of other techniques used. There were some methods they used to evade defenses by encrypting parts of the payload or obfuscating it. And then once they were on that device and had full access, what were the kinds of malicious things they were doing? Well, under collection, they were accessing the contact list, call logs, calendar, trying to get sensitive data from chat applications and that sort of thing that were installed on the device, locating the user, turning on the microphone, those sorts of things, and then communicating all of that back. And so I also wanted to also show what the network-based, so I talked about tactics and techniques to gain initial access to a device and then make use of that access. And here the attempt is to portray if the adversary can't get on the device, what are some other things they might be able to do. So an example would be a lot of mobile devices automatically back up all of their, or much of their data to cloud services. So maybe an adversary would try to figure out what your username and password is to one of those cloud services. Maybe you don't have two-factor or other kinds of strong authentication enabled, and then they could make use of that to get much of the data that's on the mobile device, but without actually targeting the device itself. So I have a few examples. So each technique on our website, there's a wiki page with a full technical description of the technique and examples of it being used, and then also what are some things that enterprises or users could do to detect that an adversary is using that technique, or what can they do to mitigate the technique. So in many cases, like Nick talked about, improvements made to Android, so in many cases mitigation would be, hey, if you have Android version X or higher installed, really this technique's just not applicable at all because they've blocked it from being usable. So an example of a mitigation, one common mitigation we've seen and that Carlton and I will talk about tomorrow is application vetting. This is a practice we see often in enterprises where before they allow apps to be installed on their mobile devices, they have some sort of review process. They put the app through to look for vulnerabilities or malicious behavior. So if an enterprise reviewed all the applications before allowing them to be installed, then many of the techniques can be addressed. And certainly application vetting can also be performed by an app store like the Google Play Store or Apple iOS App Store. And we also have examples of these software entries, which are some example of some malware, and it's a technical description of what the malware did, and then all the techniques that are being used, and all these things cross-reference with each other. So if you click on any of those techniques used, it goes to that technique page, which also lists all the malware that uses it. So all these kind of cross-correlate the techniques, the mitigations on the software entries. And so another use case we've seen for the attack model is performing a defensive gap analysis. And really this is a notional analysis that I wouldn't read into too much, but the idea here is that, say, an enterprise followed all the best practices that are out there to configure their mobile devices and put in place, say, some commercially available tools, appropriate configuration settings, that sort of thing. The goal of this is to portray for each of these techniques that an adversary could use, and enterprise following all the best practices, what techniques is there some sort of full ability for the enterprise to either prevent the technique from being used or detect if someone's using it. That's the green boxes. The yellow boxes are some partial ability, and then the orange ones are there's really very minimal ability to mitigate or detect use of those techniques. So looking at app delivery via other means, for example, the idea there is that's any way to get an application installed on the device that does not involve going through one of the official app stores that the device is configured to use. So there's ways on both iOS or Android to install apps from other sources, and so that would be certainly a common source of malware, but there's also ways that enterprises can configure their Android or iOS devices just to totally block apps from being installed from those alternate sources and really limit them to those official sources. And so then here again is the same color coding for the techniques once an adversary is on the device. What tactics or techniques could they use? Again, the same idea that these orange ones are things where we think there could potentially be more work done on either helping enterprises prevent their use or at the very least detect when they're being used. And then again with the network categories, the network-based effects. So we've colored a lot of them yellow, like these cloud-based ones. Usually a good mitigation is to turn on those stronger authentication mechanisms for your cloud accounts to prevent someone from getting into those. And then there's also mitigations for a lot of the network-based attacks, like turning on a virtual private network or making sure the applications actually implement network security properly, use of transport layer security and things along those lines. Then there's still some other areas like potential issues with the older cellular protocols and potential issues with signaling system that's used in the phone network, that there's been a lot of press around that over the last few months. And so I'll turn it back over to Josh to help me wrap things up.
Yeah, I think I have my Britney Spears mic working. Okay, cool. Yeah, so we are basically finishing up both of these frameworks, and we're really excited about getting them out there and getting the folks like y'all here taking a look at it and making it all better. We would definitely appreciate some input. We'll throw the link to the Mobile Threat Catalog on Twitter using the hashtag here, and so please let us know if you have any input or any thoughts on how we could improve this.
I'll add that the attack mobile profile, so the regular general attack focused on enterprise Windows PCs. That website's publicly accessible. The attack mobile profile work, we just got our permission to release that, so the website's not publicly accessible yet, but should be very shortly. And for general attack, MITRE's done a lot of partnerships with security vendors and researchers and others to help improve it, and certainly we know this is just the first edition of the mobile work, and there's a long ways to go, and we'd really invite contributions and feedback from everybody.
Thank you for an interesting talk, Josh and Michael. Are there any questions?
Thank you, guys. I think this looks very helpful for a certain subset of interactions. I was wondering if you have any opinions about the quality of OWASP and any opinions about how you're going to maintain a high quality of assessments in your report as you're bringing in submissions from the community.
I don't want to speak about OWASP, to be honest with you. I don't feel comfortable doing that. I don't know if you want to step up to that, Mike.
So I followed the OWASP mobile work a little bit, and it seems like they've provided working on some good guidance for mobile application developers. I don't think I'm really in a position to comment on that because I haven't been engaged in it.
All right, I'll be controversial. There are problems in it, so I'm just wondering if you guys have thought about that and how you're going to maintain a high standard in how you're categorizing these threats, and in particular how you're quantifying that a countermeasure is effective.
Yeah, that's a really good question. I mean, and we've gotten some feedback from some very knowledgeable institutions in this area that feel that without providing some sort of priority to each of these threats, so that's like a huge problem that we are saying here. Every single threat listed in this catalog is of equal importance, and so that's something that we're definitely looking at. As of right now, we are still looking at every single issue and any idea that someone has that they send our way. I mean, the best we can really do is just constantly update with new information and let the public understand how we got to where we got to, and that's what we are using GitHub for. Essentially, is traceability. And you can really see that. We had a workshop at NIST where we brought in a number of large telecoms, OEMs, and other vendors, and that one interaction really made the catalog significantly better. Like, we got 8 hours of input on it, essentially, from experts, and so maybe doing something like that yearly is going to be how we can help maintain or ensure some level of quality.
And for the general attack work, we've had a lot of success partnering with security vendors and getting their feedback. We hope that it gives them a good opportunity to point to an independent model and show how their products or services help enterprises fill certain security gaps. And so we hope with the mobile work that the same sorts of partnerships could form.
Thanks.
Any more questions?
Oh, one behind you.
Hi. The thing that I would love to see is I guess it's a bit, the thing that I see is one hole in all this is specifically like tagging library, like CVEs in like this library with this version, because then we can like do automated scans and say like, okay, you're using this, here's the CVE, you're using that library, upgrade, or we won't install this app, kind of thing. Any thoughts on that?
Oh, I mean, that's a great question. I mean, so was it CPE, Common Platform Enumeration, has some of that information available. But I'll say as of right now, the NVD or the U.S. National Vulnerability Database isn't really focused on mobile related things. There are a number of folks talking about changing that and refocusing and making mobile something that we really need to be focusing on. But yeah, as of right now, what you're looking for isn't 100% possible.
I mean, I guess it would apply. I guess it's not only mobile. I mean, it's just in like Java libraries, like Java jars. Like in the conservative side, I mean, when I'm just developing software, I don't want to do an update unless I have to, because I want to focus on the changes I want to make.
Yeah.
So like, yeah, just pay off huge from my point of view to be able to say, okay, I can ignore these updates unless this thing goes, psh, no, you have to update now. Does that make sense?
Yeah, it definitely does. I'll come see you after, and like we can look at what's missing from CPE to see if we can make it better. Definitely. Thank you.
Other questions? Okay then, thanks guys again.
Yeah.
Thank you.